Hello everyone and welcome back to Nunley Math. Thank you so much for joining us here today. I'm Aaron Nunley and today we are going to be talking about multiplying and dividing in scientific notation. Multiplying and dividing in scientific notation. Now it is important for me to point out that if you are not already comfortable with numbers in scientific notation, this is probably going to be a little bit difficult for you. So if you feel a certain level of discomfort with the idea of writing numbers in scientific notation, or what scientific notation means or is or does, you really need to go back and watch the video on scientific notation before delving into this video. So let's go ahead and get started. Just to be clear, the reason we talk about scientific notation is because of science, hence the name. In science, we deal with very, very large numbers like the mass of the Earth, or the diameter of a galaxy, or the speed of something that's very, very fast, like the speed of light, or the distance between galaxies. And when we deal with numbers that large, we have a tendency to run into a lot of zeros that occupy a lot of space and a lot of time and can confuse the calculations that are taking place with the numbers. In science, we also deal with numbers that are very, very small, so something like a decimal with a bunch of zeros and a number after it. In either case, scientific notation allows scientists to have a convenient way to write numbers that is far less confusing and occupies a lot less space on their paper. So just in a very quick review, scientific notation is where we write a number so that you have a number between 1 and 10 multiplied by 10 to a certain power. This says a number between 1 and 10 multiplied by 10 to a certain power. So for example, if I were to give you 52,000, 52,000 is a large number. We have these 3 zeros on the end that take up a lot of space. So if I wanted to write that in scientific notation, what I would need to do is move this decimal so that I end up with a number between 1 and 10. Notice if I put it here, I would have 5,200. If I put it here, I get 520. Here gives me 52. If I put my decimal right here, I end up with 5.2. Now you'll notice that's a move of 1, 2, 3, 4 places. So in scientific notation, I would say I have a 5.2. These two numbers are not the same. So if I want my 5.2 to have the same value as 52,000, I'm going to need to multiply it by a bunch of tens. How many? 1, 2, 3, 4. And so I'd write this as 5.2 times 10 to the 4th power. Not too hard, right? Multiplying by 10 moves my decimal to the right a certain number of places. The number of places I want to move is controlled by how many tens I use. That's the exponent. Down here, if I have 0.00003, this is a very small number. This is tenths, hundredths, thousandths, 10 thousandths. This is 300 thousandths, or the fraction 3 over 100,000. Notice these zeros are going to get in the way, so we want to write the number without the zeros. So I need to move this decimal 1, 2, 3, 4, 5 places so that the 3 is in the ones place. 3 is a number between 1 and 10. That's a move of 1, 2, 3, 4, 5 places. So in scientific notation, I would say 3 times a bunch of tens. Now typically multiplying by 10 is going to take this 3 and make it bigger. I want to take the 3 and make it smaller, so actually what I'm going to need to do is divide by 10 or multiply by 1/10. And you should remember from our exponent rules that multiplying by a 1/10 is the same as multiplying by 10 to a negative exponent. Now the focus of the lesson today is not on negative exponent rules, so if this is confusing to you, look up my name and the negative exponents in order to review those rules. Basically, this says use the reciprocal of 10 or 1/10 5 times. So 3 times 1/10 would move the decimal to the left and make a 0.3. Multiplied by 1/10 again would make 300ths, and so on. Multiplying by 5 1/10 is going to give me 3/100,000ths. Now, ordinarily, we don't like to leave our answer with negative exponents because it's not considered to be simplest form. Our goal today is not to put this expression into simplest form. Our goal is to put it in scientific notation. And scientific notation says I have to have a base number of 10. That's why I'm using 10 to the negative fifth instead of 1/10 to the fifth power. We have to have a base of 10. Again, if all of that is comfortable for you, you are ready to begin today's lesson. If it is not, you really need to go back and either look at the negative exponents lesson or the scientific notation lesson to make sure that you have a good foundation. Let's hop in here. Multiplying in scientific notation is actually not that hard because it looks like this: 3.1 times 10 to the 6th multiplied by 2 times 10 to the 6th. This might be maybe a mass of an object in space, and maybe this is how fast the object is traveling. If you take its speed or rate multiplied by its time, you would end up with the distance that object travels. So maybe I'm a scientist. I want to find the distance it travels. I know its mass, and I know its, let's try this again. If I want to multiply in scientific notation, I'm going to be dealing with problems like this: 3.1 times 10 to the 6th power times 2 times 10 to the 6th power. Maybe I'm dealing with the speed of an object in space, and I'm dealing with how long it travels at that speed. And I'm a scientist. I want to find the distance. I need to take the rate multiplied by the time. So this is an object moving very, very fast for a very, very long time. This would not be uncommon for an astronomer to be working with, or maybe an astrophysicist or something like that. Here's the good news. Multiplication in scientific notation is probably easier than multiplication in standard form. So what I'm going to do is I'm going to use a few algebraic properties to rearrange the way this looks. I'm going to start with the associative property. The associative property in math says that as long as I'm dealing with a long string of multiplication, like times here, and times here, or a long string of addition, if this was a plus, and a plus, as long as all the symbols or operations are all multiplication or they're all addition, it does not matter which of these things I do first. So I could multiply this first, and I could multiply this, or I could do the multiplication here first. It doesn't really matter. So since the order does not matter, I'm going to change this by getting rid of the parentheses. I don't have to do this, then this, and multiply last. I could multiply these together, and then using order of operations just work from left to right. I'm not going to do that, but I certainly could. I'm then going to use the commutative property of multiplication, which says if you have a long string of multiplication, it does not matter what order the numbers are in. I can change the order as much as I want. Addition is also commutative, but we don't have any addition here. I'm going to use the commutative property to rearrange these numbers so that the numbers without exponents are first and the numbers with exponents are second. I'm then going to use the associative property again, and I'm going to regroup the numbers without exponents together and the numbers with exponents together as well. Once I've done that, I'm just going to perform a little bit of computation. 3.1 times 2, I can do in my head. That is 6.2. And then 10 to the 6th times 10 to the 6th. If you remember our exponent rules, the rule says we need to add those 6's together to get a 12. Again, if you're unfamiliar with your exponent rules, this is going to be much, much harder. You're going to want to go back and watch our series of videos on exponents. But all in all, this shouldn't seem too bad. Now, I have gone through and done this in great detail so that you can see the thought process that gets us to this answer. If I were actually doing this on my paper, I probably would not do all these steps on paper. I would probably skip this one right here, and I would probably skip this one right here, and I would probably just write this one down. 3.1 times 2, multiply those together, that's here, and then maybe in blue, I might do 10 to the 6th and 10 to the 6th. and get the 10 to the 12th. As I got better and better at it, I might even skip this paper and just do what I've done here, jumping straight from here down to the end. However, until you've done a few of these and you feel pretty confident with it, I would not recommend that because you don't want to make careless errors that are going to make you think you don't actually understand. If you feel pretty confident with that, I'd like you to try this one on your own, showing all the steps that I use. If you feel confident in your answer when you're done, then I would like you to fast forward to the end of my explanation and just make sure that your answer is right. If you feel uncomfortable, then I would recommend watching me do this all the way through. Either way, you should be pausing the video and trying that first, and then I'm going to go ahead and keep working. Associative property says I can regroup. Commutative property says I can rearrange. The associative property allows me to regroup, and from there I'm just going to perform some computation. You might be able to do 2.8 times 3 in your head. If not, just go off to the side of your paper and work that out. You might have a nice teacher who allows you to use a calculator. I would not let my students use a calculator on this, but if your teacher does allow that, certainly you can do that. And then you've got 10 squared times 10 to the negative 4. We know we're going to have to add these together, and this is going to be 10 to the negative 2. So 2.8 times 3 gives me 8.4 times 10 to the negative 2nd. That's not bad, right? Let's try another one. I would again suggest that you pause the video, try this on your own, and then watch my explanation. I'm going to go ahead and keep going. Associative property to regroup. Commutative property to rearrange. Associative property to regroup. I'm then going to multiply the 6.4 times 3.5. I would probably have to do this by hand off to the side. There again, if you're allowed to use a calculator, you can just type that into your calculator to come up with the solution. And then you're going to do the 10 to the 9th times 10 to the 5th. The rule is we add the exponents together. This is going to give you a 22.4 times 10 to the 14th. Did you have any trouble with that? Hopefully not. There is one thing I do want to make sure that we point out. This answer will not work for us. Do you see the problem with this answer? There's something wrong with it. Do you know what it is? If you don't, go ahead and pause the video, think about it for a second. I'm going to go ahead and tell you the problem is right here, this 22.4. You see, 22.4 is not between 1 and 10. Our final answer needs to be in scientific notation, so we cannot leave our answer like it is. Instead, we've got to take this 22.4 and we've got to write it so that it's a number between 1 and 10. That's going to happen by moving this decimal. This is a 2.24. Now, in order for 2.24 to turn into a 22.4, you're going to have a 10 here because 2 times 10 gives us the 20. 2.2 times 10 is 22. So we can rewrite this first part of the expression as 2.24 times 10 to the first, but don't forget you still have those 14 other 10s. So when I combine these together, I get 2.24 times 10 to the 15th. This is my final answer. This is in scientific notation. Don't forget to always check your answer to make sure it's in the notation you want before you move on to the next problem. I'm going to have you do one more of these. Again, I would recommend pausing the video, trying yours, then watching my explanation. I'm going to go ahead and do this. Associative property allows me to ungroup. Commutative property allows me to rearrange. Associative property allows me to regroup. Again, the calculation here, 7.91 times 4.3, I would not do that in my head. I would write that out and do it by hand or use a calculator. But over here, if I have 10 to the negative 4 and 10 to the negative 6, I know I have to add those together. So whatever this is going to be 10 to the negative 10th power. I believe it's 34.013. You can double check me on that. Times 10 to the negative 10th. Hopefully, after our last example, you realize that this 34 is a problem because it's not between 1 and 10. I need to rewrite it so that it is between 1 and 10. I need it to be 3.4. So 3.4 times a 10 would give me the 34. So I'm going to write it this way. 3.4013 times 10 to the first. Don't forget you still have that 10 to the negative 10th off to the side. I need to put those together. 1 plus negative 10 makes this 3.4013 times 10 to the negative 9. Now, if you're feeling uncomfortable about this, you might want to watch it again, especially that part about converting at the end. That is where my students tend to struggle and have to spend some extra time. I'm going to recommend that you do that and maybe try a couple different examples on your own before moving on to division, which is the second part of this lesson. Also, let me tell you that if you were to type this into your calculator using times 10, your exponent key, and then putting a negative 9 in parentheses, if you were to calculate that, that would give you the standard form. You could also multiply this together in your calculator. That would give you the standard form. And if the standard forms match, that's a pretty good indication that you've done the scientific notation portion correctly. All right, moving right along. We're going to go ahead and do dividing in scientific notation. Dividing in scientific notation. This is actually easier than multiplying in scientific notation. You have problems that look like this. 9.6 times 10 to the 8th divided by 3 times 10 to the 5th. You might also see this as 9.6 times 10 to the 8th with a division bar in the middle, and then 3.0 times 10 to the 5th. Either way, you're going to do it the same way. I prefer to write it in fraction form because it makes the explanation of why it works a little easier. Here's what I do. I take my 9.6 and my 3, and I write those as a fraction. Times, I have my 10 to the 8th and my 10 to the 5th also as a fraction. You might be wondering, I'm going to erase my ink here, you might be wondering, why am I allowed to do that? Why can I take this and split it into two separate fractions? Well, if you remember your rules for multiplying fractions together, if I have two fractions, the rule is multiply the numerators. Well, that would give me what's on top here. And then multiply the denominators. That would give me what's on bottom. I've taken this and I've factored it back into the multiplication problem that would give me this answer. So I'm allowed to do that. And once it's in this form, it's much, much easier to solve. 9.6 divided by 3, I can do that with mental math. 9 divided by 3 is 3, 6 divided by 3 is 2. So this is going to be 3.2. And then over here, as long as I remember my rules for division with exponents, I should know that if I have 8 tens on top, 5 tens on bottom, I subtract the exponents and I end up with 3 tens. You get 3.2 over here on the left and 10 to the third over here on the right. And there's your solution. Now, this is not a lesson on exponent rules, so if you're having trouble with what I've done here, you're really watching the wrong video. You need to go back and make sure you understand your exponent rules before you continue. If you do feel comfortable with that, try this one on your own. I'm going to assume that you've done that. 8.52 divided by 2.0 times 10 to the 6 over 10 to the 11th. Remember, this is how we do multiplication. Multiply the numerators, that gives you the top. Multiply the denominators, that gives you the bottom. So this change is okay. I can do this with mental math. 8 divided by 2 is 4. 52 divided by 2 is 26 or 26. So this is 4.26. Our rule for dividing exponents is subtract the exponents. This is 6 minus 11, which is 10 to the negative 5th. Remember, we're going to leave this as 10 to the negative 5th because our goal was to put it in scientific notation, not in simplest form. Piece of cake, right? Give you another one. Let me erase this ink. Here we go. Try that on your own. I'm going to assume you've done that, and I'm going to go ahead and split that up. 2.88 divided by 4.0. I'm probably not going to do that with mental math. You can if you want. You might need to come over here and actually do some division. If your teacher is nice enough that you get to use a calculator, you're certainly welcome to do that as well. I probably wouldn't let my students, though. I'm not that kind. That's going to give you 0.72. And then over here on the right, the rule is that we subtract the exponents. There you go. Did you see the problem? Hopefully, after what we learned with multiplication, you realize that that's not a number between 1 and 10, and we are not finished yet. 0.72 doesn't work, but 7.2 does. I'm going to have 7.2, and then I'm going to have to move my decimal one place to turn it into 0.72. 7.2 is bigger than this, so I need to multiply by a 1/10 to make it into 0.72, so they're equivalent. And then don't forget you have your times 10 to the fourth. The rule is add those exponents together and you end up with 7.2 times 10 to the third. One last problem. Again, try this on your own with the video paused. I'm going to keep going. 8.37 divided by 9 and 10 to the negative 4 over 10 to the negative 9. I'm definitely not going to do this in my head. I would do it by hand or with a calculator and get 0.93. 10 to the negative 4 and 10 to the negative 9, I'm going to subtract these. Negative 4 minus negative 9, be careful in that computation, that is a positive 5. Again, subtracting integers is not what our lesson's about today, so if you are uncomfortable with this, you're going to need to go back and watch that video. Notice again, we are not between 1 and 10. I need to make this into 9.3. My 9.3 is one space bigger than the 0.93 I'm supposed to use, so I have to use a 1/10 to take this 9.3 and make it smaller. Lastly, don't forget your 10 to the fifth on the end, and then we're going to combine these exponents. Negative 1 plus 5 makes 10 to the fourth. That's all I have for today, guys. Hey, if you get a chance, make sure that you ring that bell to turn on your notifications. Make sure you subscribe to our channel so that you can see everything new that we have coming out of Nunley Math. I do wish you all the very, very best of luck. Make sure you join us again for our next video on adding and subtracting in scientific notation. I wish you all the very best. Take care of yourselves. Bye-bye.